Welcome, ladies and gentlemen, to section 3.3 of Mrs. Quinn's geometry. Let's start with some definitions. An angle is a zero angle if and only if its measure is zero. An angle is acute if and only if its measure is between 0 and 90. An angle is a right angle if and only if its measure is equal to 90. An angle is obtuse if and only if the measure is between 90 and 180. And a measure of an angle is 180, then the angle is straight. All right, measures of angles end up being complementary only if they add to 90. An obvious example is 45 and 45. If I add two angles together that end up equaling a 90-degree angle or a right angle, those angles are called complementary, no matter what those angles might be or what their measures might be. Two angles are supplementary if they add to give me 180, or a straight angle. For example of complementary angles that add to 90, I might use 45 and 45. An angle that's complementary to 20 would be 70. And an angle that's complementary to 81 would be 9. And so often we'll ask you merely for the complementary angle. What angle is complementary to 81? You would tell me 9. Or what angle is complementary to 43? And you would tell me 47. These two angles are complementary. All right, let's move on to supplementary angles, those that add to give us 180. And let's just name them in angle pairs. An 80-degree angle would be supplementary to a 100-degree angle. Notice that when I add them together, just like I did at the top, now I get 180 degrees. Does that make sense? How about a 10-degree angle? Now its supplementary angle is 170. All right, hopefully we get the idea. Two non-straight angles and non-zero angles are adjacent if and only if a common side is interior to the angle formed by the non-common sides. Basically, if I have two angles that share one common side, these two angles would be considered adjacent because they share this side right here. Two adjacent angles form a linear pair if and only if their non-common sides are opposite rays. That would look like this. When you have two angles that have come together to form an 80-degree angle. This forms a linear pair. Linear pair theorem says that if two angles form a linear pair, then they are supplementary. That means that if I add them together, I do get 180 degrees. Remember that your definition is different than the theorem that connects to it. The definition says that they form a linear pair if their non-common sides are opposite rays. The theorem is the one that tells you the sum of their angles is 180. Two non-straight angles are vertical angles if and only if the union of the two sides is two lines. Basically, that would look like this. If I have two angles intersecting in this fashion, these are considered vertical angles, and this is their definition. The theorem tells me something different. It tells me that if I have two vertical angles, then their measures are equal. That tells me this, that now these two measures are equal. So please distinguish the difference between the definition and the theorem. The definition just kind of draws you a mental picture. It explains what it is. And the theorem tells you something important about the measure. The theorem for adjacent angles, or for linear pairs, were that their sum of their angles was 180. The important thing about vertical angles is that their measures are equal. So be very careful about that distinguishing between definition and theorem. In each pair below, for tomorrow, on a separate sheet of paper, I would like you to explain why, that should be why, not who, sorry, why angle ABC and angle BVC in each picture are not adjacent angles. And I will see you tomorrow.